Alright, today we're going to be talking about Chapter 4, Lesson 3. It's called Multiplying and Dividing Monomials. So the first thing we're going to be looking at is multiplying. So we're going to be looking at something called the product of powers property. And what that says is if I have this expression here, a to the m times a to the n, I have the same base, which is very important. This is simply going to be, you add the two exponents together. So the base will stay the same as a, and then you're going to add m plus n. So let's look at a very specific example here so we can see why this actually works out the way it does. So let's take 3 to the 5th times 3 to the 2nd. 3 to the 5th is 3 5 times. So this is 3 times 3 times 3 times 3 times 3. 3 to the 2nd would be 2 3s. And I'm multiplying them together. So now I still have a repetition of 3s. Now I have 1, 2, 3, 4, 5, 6, 7 of them. And 5 plus 2 is 7. So let's look at some examples here then. So, example 1, there's a lot of parts to this one, but it says find each product and express using positive exponents. So, 3 to the 4th times 3 to the 6th. We are going to keep the base. We're going to add the exponents. So this would be 3 to the 10th. Letter B, keep the base. I'm going to add the exponents. There isn't an exponent here, but it really is 1. Negative 8 plus 7 is, or negative 8 plus 1 is negative 7. And it says to use positive exponents, so this would be 1 over 7 to the 7th. Remember, this negative exponent means that we're going to be flipping it to its reciprocal and losing the negative side. Letter C. Now instead of having numbers, we have variables. But we still keep the base, add the exponents. Again, there isn't one here, but really 1 is there. And 4 plus 1 is 5. Letter D, variables again, keep the base, add the exponents. Negative 8 plus 2 is negative 6. And this turns it into 1 over r to the 6th. Now, E and F get a little bit more tricky, but my process is I want to get the coefficients, which are the numbers up front, together. And I can do that because of the commutative property. Commutative property says it doesn't matter what order I multiply in, it'll still get me the same. So I'm going to move the 3 and 4 by each other, and the two y terms by each other as well. 3 times 4 is 12. Y to the negative 2nd times y to the 5th. We keep y. We add the exponents, so negative 2 plus 5 is 3. Letter F, same process. I'm going to move the coefficients by each other, so negative 5 and 3. And then move my variable terms next to each other as well. Negative 5 times 3 is negative 15. R stays the same, because that's where the base is. Negative 10 plus 6 is negative 4. I need to rewrite this using a positive exponent. Remember, this exponent only goes with the variable, only goes with the base. So it's negative 15 over r to the 4th. We do with the exponent and then the multiplication. This is negative 15 times r to the negative 4th. All right, so now let's talk about dividing. And what we're going to look at is called a property called quotient of powers property. I'm going to start with the same process. The only difference is instead of having a to the m times a to the n, I'm going to have it be divided by. Another way to do this is a to the m in the numerator, a to the n in the denominator. With multiplying, we added the exponents. With dividing, we're actually going to subtract the exponents. And I'll show you why that works. So we'll use the same two powers that we did before, 3 to the 5th and 3 to the 2nd. Now what I'm going to do is I'm going to start evaluating this. 3 to the 5th is 3 repeated 5 times, and 3 to the 2nd is 3 repeated twice. Now, when I start simplifying, I have to look for something that's in the numerator and the denominator. That's the process. Here's a 3 in both the numerator and the denominator. Here's a 3 in both the numerator and denominator. So really now there's a 1 in the denominator, and I only have 3 3s left over. So this is now 3 to the 3rd. And 5 minus 2 is 3. Let's go through some examples. So 4 to the 11th divided by 4 to the 5th. This is 4 to the 11 minus 5, which would be 4 to the 6th. Letter B, x to the 12th divided by x is x to the 12 minus 1, which is x to the 11th. Letters C and D, don't get scared of the negative signs. This is still going to be 3 to the negative 4 minus 5. Subtract the exponents. This is now 3 to the negative 9th power, which should also be 1 over 3 to the 9th. Same thing with letter D. Keep the base. I now have 4 minus a negative 3. Integer rule state, if I'm subtracting something, I'm adding its opposite. So 4 minus a negative 3 is the same as 4 plus 3. So that would be 4 plus 3, which is 7. And then last example, example 3. It says the table shows the approximate heights of some clouds. About how many times as high are high clouds than some low clouds. So here's the table. It says low clouds are at 2 to the 10th meters. Middle is 2 to the 11th, and high is 2 to the 13th. So I'm going to take these two numbers because we're talking about high clouds and low clouds. How many times as high means I'm going to divide those. So I'm going to have 2 to the 13th over 2 to the 10th. Which means I keep the base, I subtract the exponents. 13 minus 10 is 2 to the 3rd. So I could say that some high clouds are 2 to the 3rd times higher than some low clouds, but that number doesn't really make sense in that context. So 2 to the 3rd is 2 times 2 times 2, which happens to be 8. So I would say that some high clouds are 8 times as high as some low clouds. And that's how we do multiplying and dividing with our monomials. If you have any questions, please let me know. Otherwise, this is the end of the lesson.